Okay, welcome everyone. Thank you for coming. We are going to show some of the work that we have done in the framework of the CLS INFRA project. So some of the named entity recognition and aspect-based sentiment analysis notebooks that we have created. This is an overview, a short introduction of what we are going to discuss today. So first of all, we will go over the CLS deliverables again, so what was noted in the proposal. Then we will go over the GitHub that we created and all of the Jupyter notebooks that we have made for named entity recognition and aspect-based sentiment analysis, respectively. So I will introduce them to you, and then we will go through the code a little bit. But please, I know that these notebooks are very long, so I don't want to make this a tedious presentation. Please, I like to be interrupted if there are any questions about things that I'm saying that don't make sense, or if it's taking too long, please let me know, and I will go through them a bit faster and a bit more concisely. And then thirdly, a very important step in our meeting today is gathering your feedback. So we are very interested to hear what you think about our approaches, and we will go over the future steps that we aim to take together with the team at UNED in Spain. Okay. So these are the deliverables that were written down in our proposal. So firstly, we have a machine learning pipeline for the extraction of named entities in Dutch, German, French, and English. Then we have a prototype to extract relations between entities. And then we have a lexicon-based and machine learning pipeline for sentiment analysis in Dutch, German, French, and English. I will quickly introduce named entity recognition again, just to go over it so that the terminology that I'm using is clear to everyone. So very concisely, named entity recognition is the automated recognition and classification of entities in a text. So in a sentence such as Albert Einstein was born on March 14th, 1879 in the city of Ulm, for example, you can make a system that automatically recognizes the people in that text, the dates, and the location, for example. Normally, tag sets are persons, locations, and organizations. So those are the very general tag sets, but they can be as fine-grained as you wish. So if you have a corpus and you want to extract ships, for example, the names of ships, then you can build a system to extract ships from your corpus. Sentiment analysis then is automatically recognizing and classifying sentiment in a text, which is not the same as emotion analysis. Sentiment analysis returns a value on the valence of a text, so that is positive, neutral, or negative, where emotion analysis classifies a text in, for example, this text is sad, or this text sounds jealous, or that is more fine-grained, so that is more classification. They're both classification tasks, but sentiment analysis is more in positive, neutral, or negative as classes. So you can do this on different levels. You can do this on the level of the document. You can do this on the level of the paragraph or the sentence. But what we are focusing on is the aspect level, so the level of the aspect. So as you can see in our examples, sentence-based sentiment analysis, then you give your model a sentence and it returns, this sentence is positive, neutral, or negative. Well, for aspect-based sentiment analysis, you return a valence on the level of the aspect. So in a sentence such as, Rome is a beautiful city, but the Trevi Fountain was disappointing, it would return a value for Rome as a city, positive, and the Trevi Fountain as negative. Why did we choose to focus on this approach? That's simply because it allows for more fine-grained analysis of your corpus. And that is, in our opinion, that is more useful in literary historical research settings, where you may want a more fine-grained analysis of your sentences, because sentences in literary corpora, they mix valences. They are known to be very complicated in a sentimental way. So That is why we focus on this approach instead. It's important not only to tell you what the goals are of our Jupyter notebooks, but especially what the goals are not. So what we do not aim to do is to build a full-fledged tool for literary historical text. So we let go of that idea. That's simply not possible to do because literary historical text is so varied. The research purposes are so varied, so it's simply not possible to make one all-encompassing tool for literary historical text material. What we also do not aim to do is be a documentation center for all of the tools that we are using. We refer our users to all the tools and the documentation that is important to understand the notebooks that we made, but we do not list all of the things that you need to know. So for example, if you want to evaluate your model, we do not explain what F1 is. We do not explain any of those metrics. But we do refer them to other sources that explain all of the things that you need to know to work with the notebooks in question. What we also do not do is provide pre-processing steps for your data. And that is a decision that we made because these corpora are, again, so very varied. The pre-processing steps that you need to take are so very varied. So that is also something that we decided not to focus on. What our goals are is showing different ways of applying named entity recognition and aspect recognition. Also showing different ways of applying aspect-based sentiment analysis, so different workflows, different tools that you can apply and combine to get similar results. We publish helper notebooks for some common data conversion steps. We publish a helper notebook for bootstrapping, for example, which means that you create a first annotation of your data set using off-the-shelf tools, and then you load it into your annotation platform, and then you can post-correct it later, and that saves you a lot of time if you want to annotate data sets, for example. We show you how to convert your data to an IOB format, which is a format that you need to, for example, evaluate your data. We also publish example literary historical data to play an experiment with. So we have collected a big data set of travel literature, of travel logs, and we post these annotations for named entity recognition and aspect-based sentiment analysis, which we made on this data set. We post them on our GitHub, and we also post the documents that make up our corpus and the annotation guidelines that we made to make these annotations. And as I said before, we refer users to external documentation, external tools and information on some basic concepts that you need to understand, and other research papers that are very relevant for the topic at hand. And our other goal, very important, is to gather feedback from the community. So we are very open to ideas and feedback from your side and from people who are actually going to use and apply these notebooks in their research. The all-encompassing goal is demystifying NLP for the DH community. If you give a DH scholar an all-encompassing tool, you help them for a day. But if you teach them where to look for tools and what to learn, you will help them for a lifetime. That's kind of the idea behind it. Again, these are the steps that we cater to. So the creation of a data set. We provide examples of a corpus, examples of the annotation guidelines used to create our annotations. We provide the annotations themselves. We provide a notebook for bootstrapping your corpus. And then for the analysis step, we provide notebooks for named entity recognition and aspect-based sentiment analysis in different scenarios and using different approaches and tools. And then for evaluation, we have some helper notebooks for evaluation and for how you can actually evaluate your corpus on a gold standard data if you have that available. Okay, a little bit more about the data sets that we used as a kind of a use case to make these notebooks. So it is a corpus, a literary historical corpus of travel literature in English, Dutch, German, and French. As you can see in the table on the right-hand side, there are 3,320 texts in total. And they go from the 18th century until the 20th century. So that's a pretty big corpus. And as I said, the example annotations for named entity recognition and aspect-based sentiment analysis, we had 58 texts annotated of approximately 5,000 tokens for each text. So that's nice to experiment with across all of these languages. And all of this documentation on the corpus can be found on the GitHub of Ghent CDH. So that is where we chose to host this information for now. Oh, no. Remind me later, please. Okay, I'm happy that that worked. So this is our GitHub. So this is where we put the notebooks. These are the annotation. This is the annotation guide. And yeah, these are some images that I'm loading into my README. So this gives you a bit of an overview of all of the notebooks that we have made. So it gives you an introduction. And then also it shows you what each document is and what it does. So I did this for all of the helper notebooks, for the data at hand, also for the named entity recognition notebooks. I will show you this schema later in the presentation. I'm going to just scroll through to the data now. So this is the data section. It simply tells you where the data is hosted. We had to host it in a Drive folder for now because it was too big to upload to GitHub. Maybe there are better ways to do this. Please, if you have any other ideas, let me know. This just shows all of the documents that are made, also where the corpus was fetched from. So all of the different sources, so you can refer back to that. It also shows you where the metadata is hosted, also in a Drive folder, where the annotations, where you can find the annotations and all of the aspects that were annotated on this data set.
I think there's a question for you.
Yeah.
I'm replying. Don't worry, keep going on.
Okay. Okay. So going through to the notebooks themselves and kind of the structure of the notebooks, we actually cater to different scenarios. So as a scholar, I mean, a literary scholar or historian, you may have no training data available, you may have some training data available, or you may have enough training data available to train your own system. So as far as the no training data available scenario goes, we made some notebooks that cater to zero-shot learning. What that means is that you have a model that is big enough and you don't need to give it any training data. You're not training the model itself. You're just giving it some information, which could be label information, for example, or a prompt that asks for specific information. And without any training data, it can give you the entities or the sentiments that you need. We also show you the off-the-shelf tools. So some libraries such as Flare or Spacey, they are two big NLP libraries that are very vivid. I mean, they're maintained very well. Is there a question or sorry?
No.
Okay. Sorry, there was a beep. They are very big libraries that are maintained by a community, and they host a couple of models that they have trained for named entity recognition, which you can just use off the shelf. But of course, these models are trained on modern data, and that is something to keep into account if you are applying them to your literary historical data set. And then we also show a rule-based approach, which is simply based on a couple of rules that we show how you can generate the same output. If you have some training data available, then we show you how to do few shot learning. So that is when you give the model a couple of examples just to steer it in the right direction, but you're not necessarily training it from scratch. So that's also a really nice approach which we show. And then we also show how to train and evaluate your models using these different approaches here. So on the right-hand side, you see the schema. Every notebook takes text as inputs, just text files, transform them into a data frame, a pandas data frame. And then for the entity and aspect extraction and evaluation, we have 3 big notebooks. We have one that uses a generative approach. So we use LangChain, which is also an NLP framework used to make applications with large language models. And we use the large language model Mixtral to show you how to do zero-shot information extraction and few-shot information extraction. We also have a notebook using the FLAIR framework, where we show you how to use the off-the-shelf models, the zero-shot model that was made by FLAIR called TARS, and the few-shot model that was made by FLAIR. And we also show you how to train these models from scratch. Similarly to the Spacey notebook, we show you how to apply the off-the-shelf models that are provided by Spacey in the different languages. We show you how to enhance these off-the-shelf models with some rules using Spacey's entity ruler. We show you how to perform zero-shot on your data using the named entity recognition model Gleaner, which I'm not sure how to pronounce it, to be honest. Which is made available by Spacey, where you just have to give some labels to the model and your data, and then it is able to extract entities from there. And then we also show you how to train your model or train a Spacey model using the models that are available. Then the output of these notebooks, we have code in every notebook that shows you how to simply transform it to a CSV file. Which has the text and then a list of the entities that are found in that text. That text can be as long as you want. That is something that you need to decide for yourself if you are using the notebook. And this information can then be used as input for the aspect-based sentiment analysis workflows. So we have a rule-based approach, which just shows you how to use the parts of speech tagger by Spacey, and then in combination with SenticNet, which is a sentiment analysis library. And then we have a machine learning-based pipeline, which shows you how to train a sequence tagger from FLAIR from scratch, and then extract the embedding information from the results of this, and then use it as input for training your own machine learning models. But that's something that Pranay will then explain to you in more detail later. And the output of this is the text, the aspect or the entity, and then a sentiment score that is allotted to this entity. Each notebook kind of follows a similar structure, despite the fact that these packages have very different modules and things to work with. They all load in our sample data from our GitHub directly. So they contain info on how to adapt the notebooks to German, French, Dutch, and English, respectively. So we show some examples, but they are very modular, so you can apply them for each language which you want, actually. They're actually not also beyond these languages, because they're not limited to the languages that we are showing. We also provide some information on the expected background knowledge and the skills that you need to be able to work with these notebooks. We comment on every step that we take, just to make clear that why we are doing certain things, how we are doing certain things. And then we provide some extra information and source material, which could be interesting if you want to dive deeper in NLP or named entity recognition. Okay, so I suggest that we move on to some of the notebooks. So I will just go through them. If there's any questions, or if you want me to talk some more or a bit less about something, then you have to let me know. So this is an example of the bootstrapping notebook that we made. So it's pretty straightforward. It shows you, okay, gathering a corpus, creating annotation guidelines, training a team of annotators or crowdsourcing annotations. That's pretty hard work, but we do not need to start from scratch. So we give a bit of an overview of what bootstrapping is and why you would want to do it. And then we show you how to load the example corpus from the public GitHub page, as I told you, how we annotate this corpus with the off-the-shelf tool from an off-the-shelf model from Spacie, just as an example, but you can make this as complicated as you want, of course. And how you can then feed the annotations into an XML file, which is the import file for the annotation platform that we use, and that is Inception. So there's a section on required background knowledge. It says, okay, you need to know a bit about GitHub, Spacie, annotation practices, and so on. Here we load in our data set. This is the same for each notebook, basically. So it just clones the GitHub, and then the files appear in your file section right here. And then you have the texts in your Jupyter notebook, in your Google Colab, which is really nice and easy to work with. And they're all hosted on the Ghent CDH repository. So we give an overview of the annotations that can be made by Spacie. We give you an example of how it works, of what these annotations may look like for an example text from our corpus. And then, and then we go to bootstrapping with Spacie. So we simply give you some helper code, which you can then use to bootstrap your annotations. So to feed all of the tokens and all of the entities that were recognized by Spacie into your XML file, and then export it and import it into Inception. And that looks a bit like this. So you have some annotations and some are clearly wrong and need to be corrected. But yeah, that is one of the notebooks that we made. The more information section then has some more information on inter-annotator agreement, for example. What is it? Why do we need to calculate it? What are some interesting other sources to check? What are some other open source annotation platforms that you can check out? It's all very changeable and modular. This is also a helper notebook. Quite simply, to evaluate your data, you need to evaluate your spans. You need to first transform your data into an IOB format to then calculate your F1 scores. And this simply gives you some code to do that. So it takes in a data frame with a sentence, an entity text, and an entity category, and it then transforms it into an IOB. It adds a new column with an IOB format. Yeah, this is quite straightforward too. There are just some functions that you can use and reuse if they're necessary. For example, Flare, if you want to train a model, you need your IOB labeled data in a tab separated text file, like so. And this also gives you some code and shows you how you can do that. But this is simply the type of code that is a bit taken for granted, but it's nice if you're a scholar and you're starting out with that stuff, if you just have some examples that show you how you can do it. Okay. So this is the notebook of using Spacie. So again, it loads in the data. It shows you how you can apply the off-the-shelf models, how you can enhance these off-the-shelf results with some rules using regex and the entity ruler, how you can export them to CSV. Secondly, then how you can apply zero shot using Gliner to recognize fauna and flora in a text corpus, and how you can train a named entity recognition tagger for French. Oops. Yeah, again, this is a lot of information. I'm not gonna go through that at all now, but if you're getting started, it's just nice to have kind of a starting point, and then people can pick and choose what they find interesting, where they want to dive into next. Some required background knowledge again, loading the packages, loading the corpus, how you can apply generic named entity recognition using the models that are available in the SPACY documentation. So we list them here, but we also refer to the documentation. So if this changes, then they can see why their code is not running. And then it shows you how you can start building a SPACY pipeline, because that is how SPACY works. You build pipelines, and then you add some functionalities that you need. And here we show you how to do that. And then we build some helper functions, again, to label your corpus at once. But of course, this seems pretty convoluted, but it makes sense if you go through it and go through it step by step. We show you how to add some rules to your using the entity ruler and using some regex. So here we know, for example, in our corpus that we have a lot of religious figures, such as popes and saints, and we kind of know how they are represented in the corpus. So they are called Pope, Pius, da da da, or Saint, da da da. So I show you how to add a rule, which is simply a regex rule to find religious figures in your corpus. And we want them to have a separate tag. We want to have a separate tag for them called religious figure. So that is something that you can add to your pipeline, for example, and what have you. If we then apply the pipeline to a text, then we can see here that we, Pope Pius and I, were wandering in Rome, and it recognizes the religious figure and the GPE. We also show us a short example of the entity ruler. For example, we notice that Genoa is recognized as a person, organization, and the GPE, but we know that that is wrong because we always want it to be recognized as a GPE. Then that is something that we can add as a rule in our pipeline. And again, you can see in the results that it does just that. So those are very useful functionalities to know about if you want to annotate your own corpus. It also shows you how to save your pipeline to a disk, to export the results to a CSV. And then it shows you the zero shot functionality using Gliner. We use this with Dutch. Some information about the GitHub, about the models that are available, and a very big red exclamation mark that says the field is moving extremely quickly at the time of writing, and this module may have significantly changed when you're starting to use it. And then it shows you, okay, from a text example from our Dutch corpus, how you can apply it without any training data. And it's pretty impressive what it can do, just simply by giving it some custom labels, fauna and flora, no other information, and the text. It is able to recognize that the mangaboom here, I don't know what a mangaboom is in English, but it knows that it's a flora entity. So that's a very, very useful tool to use in literary historical settings, even to create silver label data sets, or yeah, a first version of your annotations. So I show you how to add it to a pipeline, and then how to apply it to a corpus. And if we inspect the results, this is, yeah, it's pretty impressive what it can do. You have a sentence here, and it recognizes snake, for example, kokos, yeah, koebeesten, which is a very, in Dutch, it's a pretty funny word, but it means cows, but in a very, yeah, very hillbilly word. I also show you how to train a spacey named entity recognition tagger from scratch. Shows you which document formats, which formats it expects, and so on. Yeah, I don't think I have to go through that. But anyway, the information is all there. It shows you how to make your train data. It shows you what it's supposed to look like, and how you can then train your own model, and save it to your save it and apply it to your own data. And also some more information about other useful sources, because other people have also created some interesting resources on Spacey for digital humanists. So it would be a bit sad not to reference them. For Flare, it's kind of the same. It's kind of the same principle. So we load in our data, we show the off-the-shelf models, we show how to perform zero shot with a model that they provided for this. At the moment, it's only for English, which is something to keep into account. But you can also train this TARS base model from scratch for any language. So yeah, that is something that is quite useful. Oh, I'm just gonna click it again for. Oops. Okay. So same principle. Loading packages, example data, shows you how to perform generic named entity recognition using the off-the-shelf models, how you can inspect the results, how you can apply them to a data frame, how you can evaluate the results on a small test set. So if you have some gold standard data available, then it shows you how you can annotate your results, how you can export them, then use the IOB notebook to transform them into IOB tags, import them again, and then you can calculate your F1 scores with a very useful package that is available for that called NerValuate, which shows you the scores on partial level, strict level, and an exact level. So that's also something modular that you can do. Yeah, zero shots named entity recognition using TARS. Kind of the same principle. You also give it, as with the Spacey Gliner model, you also give it some sentences. You show it some labels that you want to recognize. You add it as a task to your pipeline, and then it returns its results. So it found some animals apparently in these texts. So that's something that you can then apply to your own data. It shows you how to perform few shot named entity recognition with the TARS module. So you need to kind of train this module for that. Again, you can export your data, import it into the IOB notebook, transform it into the format that is expected by the Flare trainer, and then import it again and use it to train your model. And this is the same principle. So I'm not going to go over that, but this is how to fine-tune your TARS tagger from scratch. Flare also provides the sequence tagger, which I think is a different architecture, as far as I understand. But it's, yeah, you can also simply fine-tune them from scratch. And then the output of your fine-tuned model looks like this, and you can simply export it to a CSV file. Then the notebooks, the generative notebooks, they're a bit different. They use LangChain, as I said, a framework to work with large language models to create applications with them. We used the Mixtral model as a showcase, as a use case, because this is quite an easy to implement model, at least in my experience. It's also multilingual. It was trained on French, English, and German. And at the time of writing, it's also it has pretty good results on Dutch benchmarks as well, despite not having been trained for this. So we give some introduction on large language models and Mixtral specifically, where you can find it on the Hugging Face hub as well. Just it refers you to the model cards, so you can have a look at this and see if it's interesting for your purpose. Of course, we know that these using these large language models, they come with some complications if we try to prompt something from them. So one big thing is that you can never really know what it is going to output. So if you give a prompt to ChatGPT, for example, the output could be a big string, but you never really know what it's going to look like. And if we want to use it for information extraction, we actually want the output to be predictable and parsable. So sometimes if we prompt one of these models to output JSON, the JSON will be incorrect, the JSON will be incomplete, and then we will run into errors. So we show you how to validate this output from the LLM using Pydantic. So how you can make a class for your named entity recognition. So these are the entities that you then want to recognize: person, organization, location, fauna, and flora. And as you can see here, this is a partial JSON. This is wrong. If we try to cast this to a JSON object to parse later, we will run into errors because it's not closed, because it also adds some random information that we did not request. And what we can do is then add our validator to that, and then it will only take out the information that is interesting for us. So here, for example, the person in the person entity and the location entity. It shows you how to build a prompt. Again, it emphasizes that it's all a matter of experimentation, that you need to play around with this to make it fit for your own goal. Yeah, I show you the template here. So this is the template for my prompt. We add a personality. I called it a personality, which is simply extract the relevant entities from the given sentence. Your task is to identify 9 named entities in a sentence. You have to structure the answer according to the JSON entity schema, which we define here. Do not deviate from this schema. We are pretty strict. We say that the sentence is indicated by these brackets. And then we can apply it to a sentence by changing it to a prompt object and then feeding the prompt to the LLM. And as you can see, this is the response from the LLM. So it's a big string. So we need to make the prompt as predictable as possible to be able to parse this output. So as an answer, we have this, and this is the part that is interesting for us. So from this sentence, I was walking in Rome when I saw a beautiful deer and rabbits. I wanted to touch it, but it ran through the dandelions. This is what the model actually extracted. So a location, Rome, and then fauna, deer, and rabbits. So also pretty impressive, given that there is no training data at all here. And then we can apply our validator to that. And then indeed, it just gives you an easy way to then extract the results. So deer, rabbits, and Rome. Yeah, these are some functions that I show you. Simply to parse the LLM response, to create the LLM output, and to then apply it to a larger data frame. A problem, or problem's not really a problem, but something to take into account is that this model takes a maximum input of about 30,000 tokens. So we need to split up your text if necessary before you proceed. Here I show you how to do that and make a new row for each chunk. And then also another problem is that if we want to call the API here, there is a rate limit. So we cannot do that into into oblivion, sadly. So that's something that we need to take into account. And yeah, I mean, if anyone is using this notebook, then they have to take that into account. Also, that you need to set your environment first, and you have to add your Hugging Face API token. Again, here we do not show how to go through that process. We simply refer to the documentation. And that's something that they will need to figure out. So it shows you how to chunk your texts, apply it to a corpus, and then you can inspect these results manually. And as you can see, this is what it extracted from our texts. Yeah, this again, I'm always very impressed by what this can do. And it shows you how to save the results to a data frame. As you can see, there's a lot of things that are coming back. I also do the same thing for few-shot named entity recognition and aspect extraction. So this is simply a way within LangChain to perform few-shots information extraction by giving some examples in your prompt. And here I specify some examples, so some text and the answer that we expect, so the ideal answer that we hope the model will extract. And we feed this into the necessary variables. And then again, we make a function to parse this response, and we can apply it to a big data set later. So that is, again, some more information about large language models for literary historical research. We simply encourage people to choose their approach according to, and be really aware of what the pluses and the minuses are of each approach and why they would go for one over the other. Okay. Yeah, then we also have a rule-based notebook, which maybe I'm not going to open that because it simply shows you how to perform parts of speech tagging with spaCy to extract noun phrases as aspects, and then you can extract opinion words using a similar methodology. And we then define opinion words as adjectives, adverbs, and auxiliary constructions. And then we apply SenticNet, so the sentiment analysis module, on these opinion words to generate a score. That's also a very simple way of doing aspect-based sentiment analysis, and also one of the ways that is possible, one of the ways that we show how to do it. And then there's the machine learning based notebooks, and maybe I will give the floor to Pranay now. I'll stop sharing my screen.
Yeah, could you turn your microphone on?
Yeah.
And Pranay, turn your microphone on. Thank you.
I think mine should be on. Yeah.
Turn your sound off. Yeah. No.
Is that working?
And then you have to turn your sound off.
So, yeah.
Yeah, so I'll go through the ABSA notebooks, which use Flare for aspect extraction, and then just some machine learning classifiers for the sentiment analysis. And the notebooks are structured very similar to Tess's. So the main idea is that the task is divided into two parts. So task A is extraction of the aspects, and then task B is the classification of sentiment for the aspects. And initially, we decided to also split the notebook into two sections. So section 1 would be fine-tuning a model with your annotated dataset. And section 2 would have been, if you don't have an annotated dataset, how you can do zero-shot as well. But in the end, we're going to use the rule-based notebooks of Tess as section 2. So there won't be a section 2 at the moment. Yeah, so as you can see, there's the flow is similar to Tess's. There's an overview of what ABSA is and how it works. There's some links to reading material. Then we just get into installing the dependencies. Section 1 is about using Flare to fine-tune your annotated dataset. And here again, there's a few links here and there to go to the correct documentation. Then we just begin by loading the dataset. We split it into train sets and test sets. There's a overview of what the tag set means. There's a link to the data conversion notebook of Tess in case you want to convert your data to the IOB format of Tess, because we need the data in this format for the notebook. Yeah, and then we train the sequence tagger with Flare. Again, here there's plenty of documentation and comments for all the parameters. For example, for the hidden size, this is the size of the hidden layer of the model. You can change this to any other value depending on the computational resources you have. If your training is taking too long, experiment with reducing this number. So that kind of information. Yeah, so then this is the actual training. It's not run all the way, so the model isn't very accurate right now. So I stopped it in the middle so that I could demonstrate that it worked. Yeah, so then we test the model on a random sentence. It works okay, but of course it's not fully trained. And then we have task B, which is sentiment classification. And here the code is a bit more complicated. And yeah, we are looking for some feedback to make this simple and more readable. So yeah, so the idea is similar. We load in the data. This time we also have the sentiment labels with the data other than the aspect. So we have the sentiment category, which is 5, I think, means very positive, and 1 means very negative. So it goes from 1 to 5. Yeah, so again, we set up the data. We introduce the tag set. We again load a model. We indicate what this model is and how it can be used and how you can look for other available models on the Hugging Face hub. Yeah, then we just get into some helper functions. So this is where the code gets a bit more complicated and it's a bit messy. So we are looking to simplify this a bit further. And then finally, we create a torch model for creating the embeddings. And then we extract the embeddings, and then we just create our classifier using scikit-learn. So for now, the classifier is, again, just SVM, but that can be changed. Again, there's documentation and links to how to change the classifier. Yeah, and I think that's about it. We print the evaluation metrics, and yeah, that's it.
There was a question about at what level. So
right. So the level is at the level of the aspects. So it's not sentence or text level. It's at the aspect. So each aspect has its own sentiment. As you can see here, so here's the data. So in this sentence, breeze is the aspect, and the associated sentiment is to the aspect. Yeah, I think Tess can continue further. Or yeah.
Yeah, I'm back. Okay, and that actually brings us to our final slide, which are future plans and, of course, feedback from your side. What we want to do is we want to have our DH interns who are present here at the Ghent Center for Digital Humanities test these notebooks on user-friendliness, on usefulness, on clarity, require technical knowledge, and basically anything that they find relevant when they're testing these notebooks for their own data, for the data that we provided. We have, or Amanda has made an evaluation form for us so that it's easy to analyze the results. And yeah, we are also looking to do some research on historians' perspectives on AI and natural language processing in general. So that's something that we are working on. So yes,
Literary scholars.
on literary scholars in general. Some next steps are to further fine-tune and publish the notebooks. We were discussing, Pranay and I, our notebooks yesterday, and we find them a bit long. So that is maybe something that we could look into, maybe shorten them a bit. And then some of the next steps are to talk them over with the Spanish team at UNED to see where we can improve them, where we can make different versions for other languages, such as Spanish, for example. And then maybe we can, as we had discussed prior, we can publish them as a Docker instance. And we can always have a look at some other tools and approaches that we can document. And then the next step is, of course, the relation extraction pipeline deliverable, where we are also going to discuss this together with the Spanish